I'm talking about Unit 4, Worksheet 4, which is the process of discharging a capacitor and looking at pressure and pressure differences, charge flow, and bulb lighting. But to best set us up for this, we should consider what we talked about in Worksheet 3, the process of charging a capacitor. We'd established that red would represent the highest pressure, yellow represents normal pressure, and blue represents the lowest pressure. And this is the spectrum that will follow. So in Worksheet 3, we started with no battery pack in here. Everything was at normal pressure. The no battery pack had been inserted. We put in a battery pack. We charged the capacitor. As charge built up on the top plate of the capacitor, the pressure would increase. As the concentration of charge left the bottom plate of the capacitor, the pressure decreased, and we ended with a fully charged capacitor. With this fully charged capacitor, we now have the highest pressure on the top plate and the lowest pressure on the bottom plate. Worksheet 4 starts with this diagram with the battery pack removed. So looking at Worksheet 4, we start with that fully charged capacitor and the battery pack removed. On this sheet, we will need to color code, show appropriate bulb rays and arrow tails to describe the discharging process. So we start with the fully charged capacitor, and the top plate of the capacitor starts at the highest possible pressure, while the bottom plate of the capacitor and the corresponding wires start at the lowest possible pressure. Now, when we take these two loose ends of the wires and connect them, remember, a wire has little to no resistance. So when you mix the highest possible pressure and the lowest possible pressure, you would end up with normal pressure. So that middle wire then becomes yellow. Now, because the bulb is a resistor, there's not a significant amount of charge that's rushed to the bulb initially, so we're going to assume that the top plate of the capacitor is still at the highest possible pressure, and the bottom plate of the capacitor is still at the lowest possible pressure, as is the corresponding wire. Because we have a color difference across these bulbs, charge is going to flow through that bulb at a pretty good rate. So we use 3 arrow tails here. And because we have a yellow to blue pressure difference down here, which is also a 2-step pressure difference, we're going to say that charge is going to flow through here as well. Because charge is flowing through here at a decent rate, we're going to say that these bulbs are bright. And so we're going to go with 3 bulb rays here and here. Cool. Now, as the capacitor continues to discharge, charge is going to move from the top plate around the loop into the bottom plate. As that happens, as charge leaves the top plate of the capacitor, the concentration of charge drops, and therefore so does the pressure. So as that pressure drops, we're going to assume that we have a lower electric pressure. What pressure is lower than red? Orange. As charge gets added to the bottom plate of the capacitor, that pressure is going to increase. Increase in charge concentration increases the pressure. And as charge continues to flow through here, what color would this wire be? Well, because charge is still flowing, we still need to have a pressure difference across this bulb and across this bulb. So what color would fall between orange and green that would allow charge to flow? And the answer is yellow. Now, across the top bulb, we now have an orange to yellow color difference, which means we have a 1-step pressure difference. So that bulb will be less bright. The bulb begins to dim. Why does it begin to dim? Because we have a smaller pressure difference and therefore a smaller flow rate. So I'm going to go with 2 bulb rays and 2 arrow tails here. Across the bottom, we have yellow to green, which is also a 1-step pressure difference. So we're going to also say we're going to go with 2 arrow tails saying charge is flowing through that bulb but at a lower rate than before, and because it's a smaller flow rate, the bulbs will be less bright. I would also accept having one bulb ray and one arrow tail here as well. As charge continues to flow from where there's more charge to where there's less charge, or from higher electric pressure to lower electric pressure, the charge in the top plate continues to drop, and so does the corresponding pressure, leaving the top plate with a normal amount of electric pressure. And the corresponding wire between the bulbs is going to be at the lowest pressure, and as charge keeps added to the bottom plate, the pressure is going to go up from green to yellow until there's no longer a pressure difference across the bulbs, in which case the bulbs will no longer light and charge will no longer flow. Which of these circuits has the greatest pressure difference across it? Well, for figure B, from red to yellow and yellow to blue are two step pressure differences. We can tell that by the color difference. Which of these circuits has the greatest flow rate? Again, figure B. We can see that both with the greater pressure differences as well as the higher flow rates. At which of these circuits did the bulbs begin to dim? Well, they're less bright in figure C than they were in figure B. So figure C is where the bulbs begin to dim.